giving firmness to Earth, just like the stakes do. And why do we use them in everyday life? Engineers just like me, I'm an electrical engineer. I'm going to be one, inshallah. And architects use volume calculations to design containers, tanks, and structures, ensuring they meet capacity requirements. Once again, volume capacity. Beveraging in the industry, which helps them in packaging and cans, they are not going to make like every product like differently. They code the machine and give it a particular volume that you're going to put the liquid in this can, this much volume, right? Construction sites also need this awareness for cylindrical columns and conical rooms, traffic cones, ice cream cones, and various funnels. So it has a huge aspect in daily life, like a huge applications of daily life and etc. Now coming to the real part, practice problems. What is a cylinder? So basically, I have a stylus right here. I can write also, but I already did all the writing, so I'm just gonna like pinpoints some part. So practice problems. Why and how did they came in? So we know circles. I'm not going to sidetrack. If I tell you about circles, it will be a lot of time. Circle, the area of circle is pi r square, right? If I pile up circles above one circle, one circle, one circle, one circle, basically I'm piling up same radius circles above each other, just like I showed here, right? One, two, three, four, five, six. Basically, there will be like 6 million circles, but to just for convenience, I'm showing you 6 circles I piled up, right? And they all have the same radius, keep in mind. So when you pile them up, obviously the height increases. It somehow changes into a cylinder. So what will be the volume of cylinder? We know that area of a single circle was pi r square. Now, while piling it up, it has attained a certain height. So I'm going to multiply this pi r square with the height, and there you go, you get the volume of a cylinder, pi r square into height. So, and from cylinder, how you drive a cone. If we narrow down the bottom, we get 1/3 of a cylinder. This is scientifically and theoretically proved. I'm not going to prove right here, right now, because it's a demo and I don't have a lot of time. So if we narrow down the bottom, we get 1/3 of cylinder, that's pi r square h by 3. As volume of cone now becomes, look, this is, I have drew a cylinder and I made a small cone inside. Can you see it has divided into 3 equal parts? 1, 2, and 3. So if I take this first one part outside, it's going to be something like this. So this is a cone. And now you would be thinking, what would be the volume? So basically the volume would be the same, just it would be the 1/3 of the volume of the cylinder. Yeah, it makes sense, right? Math is not difficult. It's just like a puzzle. Just keep solving, keep solving. It's fun. Next, inshallah, by going to next. Okay, so I hope you have understood the concept of circle to cylinder, from cylinder to a cone, and keep in your mind that we need to memorize the formula. The formula is very important, and pi is a constant entity, 3.1415 something, and you just need to know the first 2 digits after the point. 3.14 would be enough. So let's start from simpler to then we are going to go to complex problems. Find volume of cylinder with radius 3 centimeter and height 4 centimeter. So the volume we know is pi r square h. They gave us a radius 3 centimeter. Put 3 centimeter in the part of radius. They gave us, wait a second, okay. They gave us the radius 3 centimeter. We did that. Height 4 centimeter. We did that. And pi is 3.14. Just put in the values, calculate them. Volume is 113.04 centimeter cube. Correct. I drew the cylinder just in case for convenience. The radius is 3 and the height is 4. Perfect. Okay. Find volume of cone with radius 3 centimeter, height 4 centimeter. We know that volume is 1/3 of pi r square h. That is actual volume of these cylinder. Just put in the values. Radius is 3 centimeter, height is 4 centimeter, and you get the volume, right? Perfect. I'm running out of time. I have only 10 minutes. Okay, kids. A water bottle has radius 3 centimeter. Now I'm like taking you to practical life now. So now I'm not gonna say cylinder now. Just water bottle has a radius 3 centimeter. We know that all water bottles are cylindrical, right? 3 centimeter and height 10 centimeter. What's the volume of this cylindrical water bottle? So I made one just like Stanley cups we have these days, right? V is equal to pi r squared h. Again, just put in the values, feed in the values. It's no hard. We are just taking the baby steps right now, okay? It's going to be harder, but inshallah, you will understand everything smoothly. Just don't stress it out, okay? It's very easy. Height is 10, we put the value of height. Radius is 3, we put the value of 3. 3 square is 9, 9 to 10 is 90, and 90 into 3.14 becomes 282.6 centimeter cube. And I have shown in every page pi is always constant 3.14. Okay, you have to memorize this value, pi value, and volume of cylinder, which is pi r square h, and volume of the cone, which is pi r square h by 3, basically 1/3 of the volume of cylinder. Okay, a party hat is shaped like a cone with radius 4 centimeter and height 9 centimeter. Find the volume. I made the party hat. I hope it's cute. Volume is pi r square h by 3. It's we know all party hats are just like cones, like traffic cones, like ice cream cones. Yeah, this is a cone. And put in the value. Pi is constant entity 3.14. Radius, it told us the radius of this hat was 3.14. And the height was 9 centimeters. Feed in the values, you get 150.72 centimeter cube. Whooping answer here. Okay, so my time is already over. So I'm just going to jump in the last problem. So look, a candle made from a top and bottom section. Bottom section has radius 4 centimeter and height 10 centimeter. Top section has same radius and height 6 centimeter. What is the total volume of the candle? First, we have to see what a candle is and how we are going to break this down. We know that a candle is in the bottom section, it's like a cylinder. It's a plain cylinder. And the top is conical. We know it's a cone. So I just like I wrote it down. If we break this down, the top section is a cone and the bottom section is a cylinder. By finding both sections' volumes and adding them out, we get volume of the candle as a whole. And they asked just the volume of the candle, right? So I gave you the entities. They gave you height of the cone, which was the top section is 6 centimeter. The radius of the top and the bottom is same, and it should be because they both are attached to each other, right? It wouldn't make sense if it's not same. So the height of the bottom section, which is cylinder, it's 10 centimeters. So we know that volume of cylinder is pi r square h. Pi is 3.14. The radius of the cylinder, which is the bottom section here, is 4. And the height, which is the height of the bottom section, which is cylinder, is 10. You get 502.4 centimeter cube. Check, same way. Volume of cone, 1/3 of pi r square h. And it's the top section we are talking about now. Pi is 3.14. Radius is 4. Height is 6 by 3. You get this. And to find the volume of candle hole, just add these both together. Volume candle, volume of cylinder plus volume of cone, you get 602.88 centimeter cube. I hope you enjoyed today's class and don't be scared. It's not a big deal. It's so easy. Just needs a little bit more time. And remember, practice makes man perfect. And always pray for yourself. And that's all. Assalamu alaikum.